Okay. And Professor Dmitruk, please share your monitor. And meanwhile, I will introduce our next speaker, Professor Igor Dmitruk from Taras Shevchenko National University of Kyiv in Ukraine. So he will talk about educational and research program, quantum computers, computing and information at the Taras Shevchenko National University of Kyiv. So please.
Thank you, Mr. Chairman. I'm sorry, just a moment before it suddenly freezed. So I started it from the beginning.
Okay.
I will present briefly our educational and research program for training of bachelor and master course students, quantum computers, computing and information. Can you see my presentation, or I should switch?
Everything is
perfect. We can see it. Everything works. We can see.
First of all, let me introduce myself. I work at the Faculty of Physics, National Taras Shevchenko University of Kyiv. I am head of the Department of Experimental Physics. Here are general information about our educational program, history of its development and implementation. It was developed not long time ago. We started its creation in 2017, and the first students began learning in the year of study 2018. Here is a reference to the standards. At the moment of creation of this educational program, there was no approved standard for this specific specialty. So we refer to the basics of the higher education standard projects for 2017. Now it's based on the 2021-2022 curriculum, and according to the standard of the specialty 104, physics and astronomy. Here is the reference. The first students began in 2018, and in last year, 2021, the first master course students were graduated under this educational program. First of all, I want to explain why quantum computers. To tell the truth, the stimulus for creation of this program was a reduction of the number of students. Before that, we had educational program for each department of the Faculty of Physics. Department of Theoretical Physics had educational program Theoretical Physics. Our Department of Experimental Physics had educational program Photonics. We were doing scientific research in the field of optics, spectroscopy, and photonics. But when number of students reduced, we had to arrange all educational programs in the faculty, and together with theoreticians, we came to this idea, creation of a new combined educational program. So why quantum computers? First of all, we have to take account of the lack in training of specialists. When students enter some educational program, they have to spend about 6 years, then PhD course 3 or 4 years, and approximately in 10 years they can begin their independent scientific work. So we have to suggest something that will be important, that will be actual for science 10 years in advance. It's very difficult to predict. Otherwise, we will teach students some classic things, and they will have to learn novel material, novel directions by themselves. We account that IT is very popular among young people, and they are very good in IT specialists, can find good jobs and can do research connected with IT. But in a few years, it can change drastically in near future. I often tell young students that if they learn nowadays IT, in a few years or maybe in 10 years, they can find themselves in the position of steam engine mechanics in the era of jets. That's why we have to look ahead. And appearance of quantum computers suggests that we have to switch to quantum IT. But how to train people for quantum IT while it's still developing? There is no approved standards of quantum programming. There is no very popular platform hardware solutions, so on. It's just developing right now. So we decided to teach them classic quantum physics, quantum mechanics, quantum optics, photonics, other fields of optics, statistics, and so on. And the most important, we have to teach them how to learn by themselves. And finally, we combined our efforts with Department of Theoretical Physics and came to the creation of this educational and research program. We have chosen the courses already developed at our departments that are most useful for mastering quantum physics and quantum computation. As a result of these efforts, we have prepared this educational and research program. I have to emphasize that it's a research program. It means that it's supposed continuation in master course and PhD course. We already have a PhD in the close related fields. I will show example later. Here you can find a description of some features of this educational program. We focus on developing the ability of students to solve research and practical tasks in the process of their professional activity in the field of quantum informatics, and not only quantum informatics, but other aspects of quantum physics. Since it is based on both departments of experimental and theoretical physics, it involves both aspects of quantum informatics, hardware problems and software problems, let's say. We talk much about physical realization of qubits, their interaction, properties, how to solve the problems of quantum mechanics in applications to this system, how to study quantum systems, how to create quantum dots and their ensembles specifically designed for the task of quantum informatics, and so on. Let's look at the list of our educational courses. This program starts from the third year of study. After 2 years of study of general physics and all other necessary university disciplines, students choose the specialty, and if they choose this educational and research program, quantum computers, they will have the following courses on the third year of study. Introduction to Quantum Informatics. It is taught by Department of Theoretical Physics. Abbreviation DTP is Department of Theoretical Physics. Receivers and sources of radiation. It is provided by our Department of Experimental Physics. Packages of computer calculations. Processes of absorption, propagation, and emission of light. Computerization of experiments. That is not so big list of special courses, because they continue to learn classic physics in the third year of study. They learn quantum mechanics, they learn atomic physics. So number of these courses is not so large. On the fourth year of study, we have considerably more additional sections of quantum mechanics, quantum optics, quantum electronics, additional sections of statistical physics, experimental nonlinear optics, physical foundation of quantum informatics, spectroscopy of crystals and nanosystems, plasmonics, quantum theory of a solid body, and a special seminar on the specialty provided by professors of our both departments. And if they complete these courses, they can be graduated bachelor degree. If students decide to continue their education and successfully pass entrance examination for master's course, on the first year of master course, they will have following list of special courses connected to this educational program. Modern problems of quantum informatics and quantum optics, methods of quantum chemistry, biophotonics, theory of quantum informatics and quantum optics, electronic processes and size effects in nanosystem, scientific and industrial practice in quantum computers, calculations and information, research practice in quantum informatics and quantum electronics, optics of one-dimensional periodic structures, nanoelectronics. I have to say that these practical courses, they are courses of the free choice of students. They can pick up one of these four, or one of these five: polarimetry and programming in COMSOL, multiphysics, FLEX. That is the first year of master degree. And the second year, number of courses, it's slightly smaller. Fundamental of Fourier optics, coherent phenomena in quantum systems, physics of Fullerens graphene nanotubes, theory of solitons, interaction of electromagnetic radiation with molecular systems, and specific scientific seminar on physics. The number of courses is smaller because on the third year of study, they must complete their master's project and do some independent scientific research that can be presented at the graduation. By that time, many students have published papers in scientific journals. That's why on the third year of study, number of courses is not so large. And some numeric information about this master program. Number of weeks of theoretical classes, 64, 2 years of study. Number of hours of training, altogether 930. Number of ECTS credits, 120. And they have to pass 12 exams and 13 tests. And also 4 educational and production practices. About practices, I have to say a few words more. Of course, we do not have enough possibilities to do all training, on all practical training of the students in this novel specialty. That's why we rely on the connections with institutes of the National Academy of Sciences. We have a good story of collaboration for many tens of years with this institute, and we send our students for practice to this institute, to the institutes that have good experimental possibilities and experts in certain fields of both theoretical and hardware part of quantum informatics. This practice are performed in summer times and some of them also during semesters. And finally, students have to present their master diploma, which should be real scientific work, preferably with already published papers in the journals. And also they have to pass examination in general physics. Also, I want to show you an example of what we are doing in scientific research. It's very, very brief example because I supposed to do a very short presentation. We study physical implementation of qubits by photons and quantum dots. Different aspects of qubits and quantum dots, both charge qubits, spin qubits, exciton qubits are considered. We have papers in this area. Me personally is involved in the study of quantum dots for more than 20 years. I have a number of papers in this field, and we try to attract students to this area and do joint research with the students, with undergraduate students. And also we continue, students can continue the study in PhD course. Just one example. PhD thesis was successfully defended the year 2021. Oh, there is no year here, but it was 2021. My PhD students, Roman Kolotka, defended thesis coherent properties of a single quantum dot exciton embedded in a photodiode. It was mostly experimental work, performed partially abroad, partially here in Ukraine at Kyiv University. This is practical realization of qubits in such quantum dots in photodiode. And finally, I want to emphasize again the strengths of this educational problem, and a few words about some weak sides. The strengths come from this joint efforts of theoreticians and experimentalists with good background in both fields, that we prepare students for working in quantum informatics and related areas by any means, both in some experimental research, in spectroscopy, in photonics, in nanophysics, study of quantum dots, and also the ability to solve theoretical problems. It is based on experience of professors of our departments and good connections with National Academy of Sciences. Often we invite prominent scientists from institutions of National Academy of Sciences for some specific, modern, important courses of this educational program. As of weak side of this educational program is insufficient level of opportunities for international academic mobility. We have not very much developed network of contacts with similar departments abroad to send students for practice with real quantum computers. But we suppose we can improve this situation in near future. Thank you for your attention.
Thank you very much for your talk. And now we are going to question sections. Do we have some sections? Here is, I see one question. I don't know, maybe this, what foreign institutions do your graduates work and what exactly do they do?
We have contacts with a number of foreign institutions in Europe, Germany, France, Poland, in United States, in Japan. We had a good experience of joint scientific research. We have joint projects with these institutions, but unfortunately, students' mobility is not developed so much up to date.
But what about graduates, lady?
Sorry?
About graduates, your graduates.
Follow
their career in the future?
Yeah. You can find them all over the world.
Yeah, okay. And here is a question, what is the last joint project? Do you know this? Can you? From Arten Gavrilyuk.
The last joint project. Okay. Last year we completed a NATO project with the University of Northern Carolina, and we had joint projects with Latvian Technical University. Professor Yashchuk has a joint project with Leipzig University. Okay, I'm sorry, I had to find another slide to show this contacts.
Okay.
I think it would be useful if you give links and we can put we can put these links here near your talk, and students can.
I'm sorry, I cannot present the link.
Maybe I will help you because I'm working with students from your educational programs, and some of them are master students, very nice master students, to be honest. And they have very good basic backgrounds. So maybe they need to some additional education in specific problems of quantum science. But for example, some of my former students, which are graduates from your university, are now going to defend their PhD in Olomouc University, in Pulaski University of Olomouc, in the group by Radim Philippe. So far now. So I also know that a number of other students are now, especially this is now for women, students women, because students men are now not allowed to go outside Ukraine due to war. But in this situation now, a number of women, students women who are now looking for positions. And I simply getting some requests for recommendations. So this is actually nice, not bad students, theoreticians mainly, who making very nice students, and they have applied for master positions or for master programs or for PhD positions. They're now in other universities. I know that somewhere in Austria, I don't remember now exactly the name of this university, but actually I can confirm that in working around. So with these students, they spread.
Yeah, I can show. Just yesterday, I have received this doctor thesis. How to stop sharing? Oh, yeah, here you are. It's our students graduated just 2 years ago. It's from KTH, Royal Institute of Technology, Stockholm. And I'm sorry I did not provide references, but you can find it easily in the website of university. Just go to the page of experimental physics department and theoretical physics departments, and you will find all the list of the educational courses, the lecturers of these courses, more information about scientific research, the directions and the papers, and so on. Much more information can be found in the websites of our departments.
Okay, thank you very much. I believe it's already time to close our morning section. So thank you.